Welcome, this is the sequence 1.10 solutions for the ready set go part. Here we have the ready part. The ready part asks us for each set of sequence, find the first 5 terms, then compare the growth of the arithmetic sequence and the geometric sequence, which grows faster and when. Here we have the arithmetic sequence. First term here is 2, so I'm going to plug in 2 here. And with a common difference of 3, so I am going 3 to each time. So 2 plus 3 equals to 5. 5 plus 3 is equal to 8. 8 plus 3, 8, 9, 10, 11. And 11, 12, 13, 14 would be the arithmetic sequence. Next, the geometric sequence starts here at 2, and it's also going up by a common ratio of 2. So 2 times 3 is 6. 6 times 3 is, I think, 24? No, 18. Right? And times 3, that is going to be equal to 54. Then it becomes 162. Good? Alright, so which value you think will be more at G100 or F of 100? If you already look here, if you already look at these boxes, you already see F of 5 being greater. So the answer would be G of 100. Right? Would be your answer. Because at F, oops, sorry. This should be F. No, this all should be G here. So at G of 5, because it's geometric, right? Because at G of 5, it already passed the F of 5. There you go. Next one. We have, alright. We have the first term here is 2. The common difference here is 10. Right? So 2 plus 10 is 12. Plus 10, which is equal to 22. Then it becomes 32. Then becomes 42. Likewise here, it starts at 128. Times that by 1/2, because that is the common ratio. Gets me 64 for the second term. After that, it becomes 32. After that, it becomes 16. After that, it becomes 8. There you go. So which one do you think will be more at G equals to 100? Again, here I would say it would be F of 100, because at F equals to 5, right? Because at F of 5, the value of because at the value of F5 is greater than G of 5. Good? Because the geometric sequence is just going to go down, the arithmetic sequence is just going to go up. So, of course, here the arithmetic sequence is going to be more. Alright, 3. Here, I'm just going to give you the answer. Okay, it starts with 2 here. Common difference here is 10. Geometric starts here with 2 with a common difference of 2. Here, I would say that the geometric G of 100 would be greater value because the growth of the common ratio of 2 is greater than the common difference of 20. Do you see how it's already here? Because by the G of 6, it should already be at like what? 32 times 2 is 64, right? Then it becomes 128. You see, the geometric will automatically pass the arithmetic here. Next one, 4. Starts off with 50 as the arithmetic. First term, the geometric here is starts at 1. Common ratio here is going down because D is equal to -10, but the common ratio should be R equals to 2. Sorry, this should all be common ratio. Alright. Common ratio. Alright. Because the common ratio here is equal to 2. So 1 times 2 is 2, times 2 is 4, times 8 times 2 is 8, times 2 is 16. Right here, I would say g of 100 would be a greater value because the common difference is making the value smaller, right? 50, 40, 30, 20, and 10. Whereas the geometric series is making the values larger, 1, 2, 4, 8, and 16. 5, likewise here, it starts both at 61. The common ratio is 1/2. And the arithmetic here is negative. Here I would say that g of 100 is also going to be bigger because remember, g of x will never be negative, right? It will break down into a fraction form. But the arithmetic will be a negative, okay? So g of x is bigger because it would never be a negative, right? It would be like, it goes to like 2, 1, then 1/2, then 1.25, and so on, so on. Okay. Next one, 6. Consider an arithmetic and geometric sequence where there would be a time where the geometric sequence does not outgrow an arithmetic sequence in the long run as the number of terms in the sequence become really large. What I did here is I brought the arithmetic sequence into a linear equation and I brought the geometric as the exponential. So the black line is the linear or arithmetic sequence, and the blue line here is going to be your exponential that is part of your geometric sequence. Notice that here it looks like the blue line, the exponential geometric series, is going to outtake the linear equation. However, okay, there's a proof for this, but you would have to do advanced mathematics where you would look at like the convergence and divergence of a sequence. Okay, but for this one, the simple definition would be this. Notice that the arithmetic sequence, or the linear, can behave like the geometric sequence, exponential, when the common difference, aka the slope of the linear equation, is super large, like 1 million meters per second. Hence, it goes really fast. Look at the black line here. That is the arithmetic sequence as a linear equation. See how fast that slope is, how high is how steep that is. It almost looks like it is exponential. Likewise, the geometric sequence could look linear. It can grow really small right there if the common ratio is like 1.00001. Okay, do you see how slow it grows? At this point, yes, it is possible for the linear or arithmetic sequence to outrun the common difference, the geometric. Okay, good. Let's look at the set part. Each of the table below represents a geometric sequence. Find the missing term in the sequence. Show your method. Here's your table. I'm going to use the equation method. Right? The first term is 3. The second term, it's 3 times r because you multiply it by the common ratio. The next one would be 3 times r squared because you have 2 of the common ratio, and that equals to 12. I set up my equation. I divide 3 to both sides because I am trying to isolate r alone. I am left with r squared equals to 4. To get rid of the squared, I square root both sides. Square rooting 4 gives me positive 2 and negative 2. So there are 2 possible answers for the chart. 3 times negative 2 would be negative 6, then it becomes 12. Or 3 times 2 gets me 6, then it becomes 12. Do you see how there are 2 possible answers? Negative 6 or positive 6, depending on your solution. Because again, the common ratio can be a positive 2 or a negative 2 in this case. 8. Again, I'm going to be using the equation method. The first term is 2. The second one is 2 times r. The third is 2 times r squared. The fourth is 2 times r cubed is equal to 54. So here I set up my equation. 2 times r cubed is equal to 54. Divide 2 to both sides because I am trying to get the variable alone. Gets me r cubed is equal to 27. What I'm going to do here is cube it. Cube both sides. It also looks like this. You could also say it's to the power of 1/3, right? So you could to the power of 1/3 both sides, okay? So what I'm left with is positive or negative 3. But in this case, I only use the positive term because 2 times 3 is 6, times 3 is 18, times 3 is 54. Do you see how it's all positive terms? Okay, that's why I only use the positive term of the common ratio. Let's do 9. I start with 5, blank, then 20. So To go from 5 to the next term, it's 5 times r. To the next term after that is 5 times r squared. 5 times r squared is equal to 20. So I set up the equation, divide by 5 to both sides, I get r squared equals to 4. Square root both sides, I get r is equal to plus or minus 2. Again, there are two possible choices. You could have 5 times negative 10. It becomes negative 10, becomes 20, or then it becomes negative 40. Or you could have seen it like this: 5, 10, 20, then 40. Okay, because there's that gap here. There's two possible answers: your positive and your negative 2. Okay, good. All right, next 10. Again, I'm following the same format. I'm using the equation format: r times r, 4 times r squared, 4 times r cubed, 4 times r to the power 4 is equal to 324. So here's the equation. 4 times r to the 4th power is 324. Divide 4 to both sides. I am left with r to the 4th power is equal to 84. You do not cubed, you 4th root here. Okay? Here it's to the power 4, so you're going to 4th root both sides. What that means is r to the 4 is to the 1/4 power. 81 is to the 1/4 power. Okay? If you do that in your calculator, right, it should look like that in your calculator, right? R is equal to 1 plus or minus 3. So it can be 4 to negative 12, 36, negative 108, and 324. Likewise, it could be 4, 12, 36, 108, and 324. Because of those gaps, you are allowed a positive or a negative value of the common ratio. Here's the go part. Given the following information, determine if the explicit equation for each geometric sequence. So I am only looking for the explicit, but I think here I gave you both the explicit and recursive. Okay, so here the f of 1 is equal to 8. The common ratio here is 2. Okay, so oh no, this is the explicit. Yes, this is just the explicit. So f of 1 is equal to 2. Is 8. F of 1 is equal to 8 because that's the first term. The common ratio here is 2. Let me color code this so you could see what I am referring to. Okay, so you're not completely confused. All right, do you see that? That's where you're making that substitution. R, which is, I can make that blue for you. All right, that is the R here. And that's going to be the R here, which is the 2. There you go. 12. First term is 4. This is the, looks like that is the common, no, this looks like this is the recursive. 3 times the previous function. So the common ratio here is 3, right? So I plug it in again for the common ratio. For the 3 here for the R, as well as the first term here is 4. Next, 13. Again, I have the recursive and the first term, so I substitute that in. 14, which geometric series above has the greatest value of f to 100, a function of 100? I would say 5 to the 3rd because it has the largest common ratio of r is equal to 4, right? Because look, common ratio of 3, common ratio of 2, right? Because this has a common ratio of 4, it's going to grow the fastest. Okay, so there you go. That is your solution for the sequence of 1.10.